This lesson is on converting exponential and radical forms. So we're going to go from an exponential expression to a radical expression, and from a radical expression back to an exponential expression. So the first thing we're going to do is talk about the parts of a radical. So we're going to look at this here, and what we've got is the piece on the inside, that A is known as the radicand. So whatever's inside that radical symbol is called the radicand, and this is the radical symbol. This piece right here is the radical. Whatever's inside is the radicand. And then that little n on the outside is called the index. So for example, if we have a radical symbol that looks like this, that index is 3, that's a cube root. If we have one that looks like this, the index is 4, that's a 4th root. If there is no index, it's assumed that the index is 2. So if you have this without any number, that's just a square root. So we assume that there's an imaginary 2 right here. And that's going to be very important later. Now we're just going to have a quick little lesson on roots and the number of roots. So all of these examples will have real roots. We're not dealing with any imaginary numbers yet. So if the index is even and the radicand is positive, so if the index or the number outside the radical is even and the number under the radical is positive, then there's going to be 2 roots, a positive root and a negative root. If the index is odd and the radicand is positive, it's going to have 1 root and it's going to be positive. If the index is odd and the radicand is negative, it's going to have 1 root and the radicand is negative. And we're going to go over some examples really quickly. So if I look at the square root of 16, that's an imaginary 2 right there, right? So I have an even index and a positive radicand. So what that means is that the square root of 16 is 4, but it could be positive 4 or negative 4, because positive 4 times positive 4 is positive 16. But negative 4 times negative 4 is also positive 16. So there are 2 possible answers to that. Now looking at the next one, I've got an odd index and a positive radicand. So it's only going to have 1 root and it's going to have to be positive. So I know that the cube root of 8 is 2. And it has to be positive 2, because positive 2 times positive 2 times positive 2 is positive 8. But negative 2 times negative 2 times negative 2 is negative 8. So that one won't work. And now I want you to try those other ones on your own. Okay, so let's go over the cube root of negative 125. Well, the cube root of 125 is 5. And because that index is odd and the radicand is negative, it's going to be negative 5. Because negative 5 times negative 5 times negative 5 is negative 125. Positive 5 cubed would be positive 125. So that's not going to work. Looking at the next one, I know the 4th root of 1 is 1. Now that even index and positive radicand tells me that it's going to have 2 roots. So that's actually going to be positive 1 and negative 1. Because 1 times 1 times 1 times 1 is 1. Negative 1 times negative 1 times negative 1 times negative 1 is also positive 1. Now we're going to look at actually changing some exponential to radical. So when I look at this, the base number becomes my radicand, or the number inside. My numerator becomes my inside exponent, or my power, and my denominator becomes my index. Try to get some color coding to help out. So looking at some examples, the base number becomes my radicand. So let's do my radical symbol. The numerator becomes my inside exponent, and the denominator becomes my index. So I'm going to have a radicand of 6 raised to the 3rd power with an index of 2. Now that's probably going to be written like this because I don't have to write an index of 2, it's just assumed. So looking at the next one, I'm going to have a radicand of 2 because that's my base number, raised to the power of 5 because that's my numerator, with a 3rd index or a 3 index. So that's the cube root of 2 to the 5th power. Now I want you to try the last 2 on your own before we go over them. All right, so the first thing I'm going to do is draw my radical symbol. I know my base is 7, so that's going to be my radicand. My numerator is 1, so it's going to be raised to the power of 1. And my denominator is 2, so my index is going to be 2. And that's probably just going to be written like this, because a 1 exponent and a 2 index are just assumed. We don't have to actually write those out. Looking at the next one, I know I'm going to have a radicand of 4, because that's the base, raised to the 4th power with a 3 as an index. So the cube root of 4 to the 4th power. Now we're going to go radical to exponential, and so basically we're just going backwards. So the index becomes the denominator of our fractional exponent. The power on the inside becomes the numerator. And the radicand becomes the base. So my radicand becomes my base. My index becomes my denominator. My inside power becomes my numerator. So looking at that first example, I'm going to have a base of 7, a numerator of 5, a denominator of 3. So these are equivalent. They're just different ways of writing it. I'm also going to do this last example because I want to show you something. This can just be written like this: the 9th root of 63 to the 8th power. Because what this is really saying is the 9th root of 63 times the 9th root of 63 times the 9th root of 63 8 times. One, 2, 3, 4, 5, 6, 7, 8. And when we multiply exponents or radicals that have the same index, we just keep the radical in the index and multiply what's inside. So that would be 63 times itself 8 times, which is the same thing as 63 to the 8th power. So just so that you've seen it before, that's another way to write that. So in that case, I would have a base of 63, a numerator of 8, and a denominator of 9. Now I want you to try those middle two on your own. Okay, so going over those middle two. On that second one, I know I'll have a base of 93 because that's my radicand. I'll have a numerator of 5 because that's my power. And I'll have a denominator of 8 because that's my index. So that's 93 raised to the 5/8 power. On the next one, I'll have a base of 22, a numerator of 7, and a denominator of 5. So this is a pretty easy concept. You just have to memorize where each piece goes. And we are just rewriting. So they're equivalent. We're just writing them in different forms.